Hey folks, how you doing today? Happy Thursday. Here's to hoping the power stays on today. Thanks for being flexible last week about that, sorry. Hopefully last semester's recording wasn't too terrible. I didn't have the nice fancy setup or anything yet. That was new near the end of the semester. But you can still see my screen and see me. The chat wasn't there, but hopefully that worked out okay for you. So, hey, Soulstar 911. Good to see you folks along. All right, so we missed or did the recording for the Intro to Web Development with PHP, sort of basics of web server requests, what happens here, and then starting with some basic PHP, getting into loops and things. So for the project, you shouldn't need any loops. Capsules on. No problem, Casey. So and loops are good. We'll be using them later. But so in terms of project one, it's just a basic form, and then we're going to post or get do a get request. Is probably the appropriate request there. Typically, if you're just getting data or doing a lookup, essentially a read-only sort of operation, it's a get request. Versus if you're changing data or saving data or that sort of thing, that would be a post request for the different form types there. So get, I think, is more appropriate for this calculator. So we just start with an index page. It's got the fields you fill out, right, for your adjusted your gross income and your total deductions, and we just send that data over to the tax calculator page. Then the tax calculator page does all of the good stuff. Okay, so that should do all the things it needs to do to calculate your earnings there. So this week, we're going to talk all about databases. So if you've had the Intro to Database course 1200, you're probably going to be bored, I apologize. But it's not a prerequisite for the course, which is a little weird because we're going to write applications that interact with databases from here on out. Project 2 and on out, essentially, will be database-backed projects. But you don't need tons of database knowledge to do it, and the tools are actually really helpful and pretty easy. Intuitive might be the wrong word for it, but I'll help you with any of the database stuff specifically. Yeah, even the web programming HTML courses aren't prereqs. That's also a little weird. So in Inferno, though, we don't, or Inferno, I'm not big on any of the design part of things and making things look pretty. Again, that's all stuff you can tackle later. So the focus of this class is on the server-side web technology. So anything client-side, that's all JavaScript. We'll get to just a little bit of doing AJAX and some asynchronous requests at the end of the semester. Hey, King, how you doing today? But again, the focus is more this server side. So PHP, all of those requests, right, as we talked about last week, are being processed and done on the PHP server, the web server, and then it's just sending the response back to the client. So all the work is happening on the server side, and that's what we're focusing on for PHP and for JSP as well. So you don't really need lots of other web knowledge. All the examples are pretty easy to copy off of the textbook, and I'll be going along with a similar project example, trying to build it out as we go, and we sort of build on that as we go. So I try and give you a lot of that scaffolding, and then we just kind of go fill in the blanks. Yep. So the actual calculation part that'll take a little bit of work. Hopefully you folks have had a chance to find a learning partner. If you need to trio up, that's cool. But if you've got 4 people, that's essentially 2 pairs. So you can break off into 2 pairs. You are more than welcome to talk with each other about the projects, right? My usual guideline for that is if you start taking notes, you've gone too far, right? If you're like writing down the things your partner is saying, we've gone too far into that copying, cheating realm. But if you're just chatting, like, hey, this is my idea, this is what I'm going to do, you know, if I have a loop to do this, or I'll calculate it this way, or that sort of thing, that's all fine. I'm happy with that. No issues there. Are the requests similar to web, get, post requests in JavaScript, other languages? Yeah, so it's just a an HTML form. So we just use the basic HTML form for now. We're not doing anything super fancy. Yeah, it is an HTML form. You don't need any PHP actually on the first index page. It could just be a static HTML page. It doesn't even really need to be a PHP page. I think page is redundant there, but that's okay. Don't worry, I've got the band Hammer King. Yeah, Git would have been perfectly fine for the VMI calculator. I think they were just trying to show the different examples, and until you really have like a database-backed application, I mean, a post isn't really doing a whole lot on the web server anyway. So let me pull up my little tax calculator here. Come on, NetBeans, cooperate today. I don't need that one. Close those other projects. Nope, not that one. This index page, there we go. Yeah, you can use Git or post, either one. So Git is typically, again, for read-only. Post is for if you're going to be submitting data or changing data. For our purposes, it's not going to matter. Once we get to our database-backed applications, the correct way to do it is with a post. They essentially do the same thing, but yep, no problem. It's okay if you did either one. So like this is just, there's no PHP at all in this one here. Right, just here's a text box, here's an input label, and then here's my submit button, and it sends it to my tax calculator PHP page. Right, the tax calculator is where you actually do all of the PHP work to calculate all your variables and echo out all the stuff you need to echo out. So we should be good with that. Let's close these other ones. So if you just wanted to see it running again, yep, I think I'm good in Firefox. So I had this when I did the video last week. Hopefully you folks got. Am I back? Oh, man. All right. I think I'm back. I don't know what that was. That was weird. Oh, it totally dropped the stream on me. I just like disconnected it and reconnected it. Gone. All right. All right, we'll give it a second then if there's a little ad break. I'm pretty sure the only service providers out here are Comcast and AT&T. And AT&T is running fiber to the new neighborhood they're building behind me, but not to my house, which is really unfortunate. So all I get is their like DSL amped up version. It only gets like 30 megabit if you're lucky. So it just did not handle everything happening at home, unfortunately. So Comcast, you know, the speeds are good, but it's flaky, which is really unfortunate. Yeah, Sean, you should get a new modem then, maybe. That's what it is. Yep. All right, so our form here, the action is what will send, is where it's going to go. And you can either get or post. Again, get's probably more appropriate, but it's fine either way. I'm not too concerned. All right, so then the tax calculator page will get the request. So it opens up here. We get our basic boring page here. And we can enter some gross income and total deductions. Hit calculate. It sends us to the page. Remember, this is a GET request, so it goes in the query parameters here. And then we get a nice little output here. what is it, Wide Open West? I used to have WoW when I lived in Farmington Hills. They were the service provider for the complex there. Right, so again, I just like showing these gross income total deductions. And I'm using the married brackets, so if you're using the single brackets, it'll be different. It'll be different. But this way I can see, am I getting the right parameters out? And then with total deductions, right? If this was less than the standard deduction, we should get the standard deduction. What is the adjusted gross income? And then taxes for each bracket. Yep, that's fine, Soulstar. No, not a problem. And remember, you pay taxes at the bracket in which the income is earned. So no matter if you make $100,000, $10, or $10 million, everyone pays the same 10% on their first $19,750 of income for married brackets, right? And check out that MoneyChimp link for the other ones. So just because you end up in the 37% bracket does not mean you pay 37% taxes of your income in taxes, right? So if we look up that MoneyChimp link, what's it, MoneyChimp tax brackets. Here we go. And if I do the married for 2020, let's see. So we need to get over 622. So okay, so let's go say 750,000. Right? We hit the 37% bracket, but only the income above 622,000 is taxed at that 37% rate. So your total tax as a percentage of your gross income and your total tax owed as a percentage of adjusted gross income here. Right? 27% of your gross income with these deductions and whatever. This is a little bit simplified version of taxes, but so that's my little warning. Don't actually use this. Please, this is not actual financial advice, tax advice. We're just trying to go through the process here. Yeah, we've got a crazy system, King. It's just a crazy system, and I don't understand why it's as hard as it should be. But that's okay. There's reasons. Reasons we pay taxes through payroll deductions. So, that's taxation without representation, right, King? Is that what you're saying? You can tax what you can't vote. Well, Soulstar, that would just be too practical to teach in school. No, I always like using this tax calculator assignment. I have to use it sparingly though, because people post things online all the time on Chegg, and then I have to spend way too much time filling out paperwork, failing people. But again, I think it's a interesting assignment. Helps get you through using some if statements, that sort of stuff, for some logic, doing some branching, and then most people have no idea how taxes work anyway, so it's a good eye opener for people. Although I did one time, this was a couple years ago now, I had a student come and tell me that he showed his dad the assignment, and his dad said that's not how taxes work, and I was doing it wrong. So, even adults get this stuff wrong. But that's okay. That's what it is. Yes, this is the progressive tax brackets, right? So as you make more money, you pay a higher percentage of the more money, not of all the money, only the more money. Okay, and that's how that works. We okay with that? Does that make sense for what we're looking for? I don't know why I'm we. I'm sorry. I think we is my preferred pronoun. I got in the habit a long time ago, and I can't break it, despite hating myself every time I say it, because I sound like an idiot when I call myself we. But hopefully that makes sense. Yes, hydration. Thank you so much, King. Finishing off this little Pellegrino here. It's good stuff. All right, So again, these are the married brackets. You can use the individual ones if you want. I don't really care one way or the other. I can probably figure out which one you used. Yep. Is that the Bang energy drink? I used to be real big into Red Bull and Monster, but now I'm diabetic, so that sort of is bad for me. And the diet ones, yeah, I'll do that if I need to, but I try not to. Oh, the Bang one are sugar-free? Okay. Usually those taste really gross, but I mean, I don't think anyone drinks energy drinks for the good taste of it, so. I don't know. I like bubbles. It's more satisfying to drink than just plain water. So. Oh, pretty good. Maybe I'll have to check it out then. Yep. Perrier. Not a sponsor. I'm really interested in it being sugar-free and tasting less chemically. That's really interesting. But I mean, usually it's coffee most of the time, but I finished off all my coffee, so my mug is empty and I'm sad. Yeah, I got hooked on sparkling water when we spent 7 weeks in Ukraine adopting, and you can't drink the tap water, so you have to buy bottled water. And most of the bottled water was sparkling already, and we ended up liking it, so I got used to the taste of sparkling water. Okay, so project 1. Any other thoughts, questions, concerns? Feeling okay? We got one more week, and next week at 6 p.m. this sucker's due, and I can't take it late because at 6 p.m. I'm going over the solution for it. Okay, so that is a hard deadline. You do get partial points, so turn in what you have, right? Take a look at that rubric here, and if you don't get it all done, that's okay. You'll get partial points for the pieces you did get done here. So, excuse me, in the rubric, right, I already gave you this, essentially. All you have to do is pause the stream and you can copy it. 1 point for that. The tax calculator page actually gets the get data or post. You know, that's okay if you did post. It's all right. Displaying the taxes owed at each bracket, that's the bulk of the points here. So the brackets, you should not see any taxes past the bracket you're in. That's correct. Yep. So if you don't make it, you know, past the 22% bracket, you pay nothing at the higher rates. Yep. No, I think get forms are perfectly fine. There's nothing wrong with that. Yeah, I mean, you're just sending numbers here. It's not any like personal identifying information here, for sure. And then the nice thing, like, you can just save this page, or like I could change it and be like, hey, I want more deductions. I'm claiming $100,000 in deductions, which I think a lot of people making this sort of money might anyway, because the tax system is a game, I guess. King, you got it. You got it. I've just gotten a bunch of other new ones here, which is awesome. I've been collecting them to try and have fresh stock for all my jokes. Here we go. So, how much room is needed for a fungus to grow? As much room as possible. Yeah, the cheat codes to the tax system. Ireland is I'm hoping something happens with global tax reform. No, I mean, you know, you send get data to Google for Google requests. It depends on the kind of data that you're submitting. It really is. You know, if you just go do a Google search and you search for PHP, here's your search right here, right? Because it's read only. We're not. I mean, you know, Google is tracking everything about us, so it's not actually read only, like all this other nonsense junk here. What is even all this ugliness? But that's fine. Right, GET requests are okay. Yeah, but you definitely don't put sensitive things in a GET request. But we'll get into a little bit more of that later, and in using secure connections as well. We're not going to get too deep into that. There's a whole class on administering PHP servers. So we'll look at, hey, this is like how you do it, and that's essentially it. We don't get into too much because, again, this is focused on the development side of things. Okay. All right, cool. So it looks like we're pretty stable here now. That's a good sign. All right. So again, tonight is all about relational databases and the MySQL server. So we're using MySQL because it's free. And actually, the one that comes with XAMPP is not actually MySQL. It's MariaDB, which is essentially the same thing. For our purposes, we could care less that they're different. It's just what it is. So MySQL, MariaDB, open source database management systems, relational database management systems. You can do some really cool stuff with. So you start up your Apache server in XAMPP, and then you start up MySQL, and we're off to the races. Okay? So this is where all the good stuff happens. And if you click config, no, admin, is that it? Admin should launch your local host. So I changed my Apache to 50,080 because I had something running on port 80. If you didn't do that, that's fine. It should just launch here, and it goes to this page called Phpmyadmin. And this is where all the magic happens. Maybe the magic happens. Come on. Let's see if Firefox has any better luck. We're just hanging out. Nope. It's up and running. I've not done a whole lot with Docker myself. Git, yeah, we're using Git as a source control tool, just a real basic level right now. Thugmuffin, is that what it is? Thugmuffin? Yay, it loaded. Okay, cool. So it just took a minute there. Here, I'll just do it over in Firefox because that's where everything else is. All right, so this is the Phpmyadmin. So this is the MySQL Server administration tool that's built in PHP. It's actually pretty cool. So you can like edit it yourself if you so cared to. Oh, what warning do you get? That's interesting. So you can see it's actually MariaDB. That's okay. It's essentially the same thing. It knows this is on the Apache web server, which is pretty cool. Huh. Potential security risk. That's weird. Is it only in Firefox that it does it too? Yeah, Git's fantastic. I use it in all my classes if I can help it. So this is telling us all about our SQL server, or MySQL server here. It shouldn't have gone to an SSL port, though. Like, it should have gone to your HTTP port, but I mean, we can look at it later, Mark, if you're worried about it. Okay, advance and continue anyway. Cool. Yeah, or maybe check to make sure you're using the non-secure port. Okay. Cool. So the idea with a relational database is that's how it stores information. So most of what we're going to do today is on whiteboard. We're going to draw a lot of pictures. Clear this off here. So when we think of storing information in a database, right? That force SSL. I mean, mine didn't, but I don't know. That's interesting. When you store information in the database, right, a lot of this is very similar to the way that we design objects when we do object-oriented programming. Right? Typically, we have some sort of noun, right? And the noun has a list of attributes, right? So if we said, hey, I want to look at the noun is going to be mug, and things about mug, right? Things that mug knows about itself. It knows its color, its size, probably knows, you know, how much fluid is in it, current fluid or something like that. Current fluid. I don't know whether or not it has a handle. Right, any sort of attributes about mug. that you can think of. If we're designing a class in code, right, we'd write the class, these would be private attributes, this sort of thing. And you'd make instances of mug. So I could have my Disney mug here, right? That's nice and large and blue with all sorts of other colors. I could have my chest bra mug over here, which is gray with their logo on it. Still also large, but not quite as big as the Disney mug. Let's see, do I have another? Or maybe you call this one a mug, a little mason jar. It's not exactly a mug, but that'll do. You got it, King. Let's go with the chess hat today. All right, how's that? You got it, King. All right, so again, we have the noun and we have its attributes. We do a similar thing in database land when we're designing databases. Now, it's not always the case that it's always a noun, but again, it's not always either when we're programming with classes, but it typically is. So you'll imagine you're going to make something called a table. The table has a name, so this might be our mug table, and then it has columns, which are the attributes. Here, so we'd have, this is, color, and size, and fluid, and handle, this sort of thing, right? So this is information about the mug table, right? Attributes about mug that go in the table. And then what you get is you get rows in the table. Each row is essentially an instance of that noun, right? So I have my blue, probably 32 ounces. It's empty right now. Yes, it has a handle. The gray chest bra mug, I think was 24 ounces maybe. It's empty. Yes, it has a handle. And then my clear, that's a 64 ounce mason jar. It's empty. No handle, right? So I'm just putting information in. So if you're familiar with Excel and Excel tables, this will look very familiar. Okay? So that's basically a table. Now, some other interesting things. In a relational database, there's a couple rules that we follow most of the time. They're not hard rules that you have to do every single time, but they're generally good recommendations. And most of the time you want to do them unless you can come up with a really good reason not to. They're called normal forms. So you have first normal form, you have second normal form, and you have third normal form. There's also a couple after that. We most of the time don't care about those. So third normal form is usually our goal here. Right? That's the one you get the prize for getting. Again, usually. And, take the database class, you can discuss all this other stuff. But what that means is, first we have no repeats. No repeats. What that means is if I'm not going to have one field. This is like a field here, this attribute, it's also called a field, with multiple values. So you get single valued fields. So in our mug example, that's not so bad. A lot of times you might look at, this is a person, and person then would have an address, right? Is one of their fields here, and maybe you have some address here. But what if they have another address, right? They might have a mailing address, and maybe they'll have a vacation address or a winter address. You put another one in here, you've got repeating fields. That's bad. Okay, you can't put more than one piece of information in the table at once. Right? Each field should have one piece of data, essentially. And then, to break that down even further, is really address is actually bad too, because that should be broken out into street, city, and zip, and state, right? And again, if you're supporting international, state, city, zip, those are a little awkward occasionally, so it gets even harder sometimes. But that's okay. We'll just pretend this is always US only. So we can break up that field as well. So it's not really multiple pieces of the same data. It's not a repetitive field, but it's just too big. Right? That's the problem. And And then there's another concept that we're going to talk about is called the primary key. So usually we say PK for primary key. The primary key is your main identifier. So this is how you would identify a row, right? How would you uniquely identify this row in the table, this instance? Now, I'm a really big fan of using generated primary keys because the computer does the work for me. So I'm going to show you how to do that. You add a field like ID, and then it just auto-populates 1, 2, 3, 4, 5, on and on and on and on and on and on and on until you get to about 2 billion some, and then you run out of integer values. Okay, but being a primary key, a system-generated primary key, yeah, this identity auto-increment is fantastic. It generally will make life easy. It doesn't have to, though, and some people will say, well, no, that's a bad idea, you don't want to do that, and sure, they have their own arguments, and that's okay. So your primary key can be another field. Oh, King, I love it. Nerd jokes. 8 bytes walking into a bar. Bartender says, "Can I get you anything?" Yeah, reply the bytes, make us a double. It's a good one. So, to uniquely identify a person, you might say driver's license number, right? Driver's license number would uniquely identify them. Probably, if you're talking about people in Michigan, that's a good unique identifier. Across states, though, you probably also need to know the state and the driver's license number, right? So a unique identifier could be a combination. So your primary key could be a combination of fields. That's called a composite key. Right? Composite, it's composed of more than one value. That's okay. I find those awkward and hard to use. And again, I'm all about easy. Like any good developer, I'm lazy. In that I'm efficiently lazy. I don't want to do more work than I need to do. And a system-generated primary key is the easy way to go. But there are other options, and that's okay. And again, take a database class, look at some of those reasons you might want other keys, that sort of thing, perfectly fine. Yep, you can use existing fields, yep. Sticks, it's definitely lazy, but also efficient. So another thing you can do is you can have other keys. You can add another unique constraint as well to say if you don't want, so like email address maybe, right? So someone had mentioned email. You probably don't want the same email address in there more than once. Yeah, Thugmuffin, I read about that Boeing plane had to reboot every so often. It kept, what is it, integer value of number of seconds or something like that that it's been on. Software is funny like that. So you can make other unique constraints if you want. Just because it's unique doesn't mean it has to be the primary key. It could be. It's considered a candidate key is another term for it. Lots of database terms. Don't worry. Take the database class. It's a fantastic class. It is one of my favorite ones to teach as well, even though it's not a programming class. Databases are great. So again, a way to uniquely identify it. So, okay, so person, again, let's just cheat. We'll say here, I've got an ID here. So 1, 2, 3, oops, probably don't start one of the headers there, right? ID 1, 2, 3, right? So Michigan, my driver's license number, address, right? Email address, et, ... right? Sure, and then we can add another person in here, and we'll add my wife, Jasmine, hers is an S something, same address, different email, right? Sure. So now I just have two different tables here, right? So I've got a table of people, I have a table of mugs, that sort of thing. How do they relate? And that's what relational databases are all about. Relational database management systems are all about, is how do I relate these things to one another? So if I wanted to say, hey, who owns this mug? Whose mug is it? Right? Well, we could have all of this information about person in over here and have duplicate information. And hopefully you've done enough programming and the word duplicate just gives you shivers, right? Essentially, anytime you have duplicate information, a bad thing is happening, right? So we don't want to duplicate any information, right? We want to say, hey, how can I reference the owner of the mug? And well, do we have a way of uniquely identifying a person? Yes, we do. We have their primary key over here. So I can uniquely identify a person as the owner of the mug using their primary key in another table. So what we do is we call that a foreign key, because it's a key that's foreign to this table. It doesn't belong, it's not a key of this table, it's a key in the other table. And we might say this is person ID, right? And I can say, hey, this mug belongs to Eric, this mug belongs to Eric, the mason jar is my wife's. Sure, go for it. Yep, our foreign key. So then it references, it relates to, so mug relates to a person. Okay? And there's all sorts of fun ways you can design databases. People love this entity relationship diagram. They are fantastic. So you'd say mug, you'd say person, you'd list out their attributes. It looks a whole lot like UML. There's no methods though, so it's like the name and then here's the attributes, right? So color, dot, 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 and then person ID, and then up here, you know, we've got an ID, and we got all those other fields here. And we'd say, well, how do these relate? Right? Well, one mug is owned by one person. Right? So we'd say one mug is owned by one person. And you know, if you're fancy, you'll draw the lines this way. Or if you use a fancy tool like Visio or something like that, we draw it from the connecting the related fields, the foreign key field and the primary key field that it references. Sure, we could do that. So one mug is owned by one person. This is crow's feet. Don't worry too much about the notation. I'm not going to ask you for it, but I want you to have seen it. Can a mug own a person? No, I don't think so. Don't think so. A cat can own a person, yes, but not a mug, right? But then one person can own many mugs, right? We're not saying you can only have one mug. So the many notation, and this is why they call it a crow's foot, looks like this little 3-branch thing, like a crow's foot, you know, with three little claws or whatever. Sure, that's the crow's foot. So this is many. Right, this is one. Okay, so one person can own many mugs, but each mug is owned by one person. And sometimes they'll even put that verb in here too. They'll say like it's owned by, and then they might say owns. Right? So a mug is owned by a person, person owns mugs, many mugs. Right? And all of this it's just giving you a visual representation of how do these tables relate, or how do these entities relate. And entities are essentially what we'll call these tables. They're entities. How do they relate to each other? Oh, that one's empty. This one here. Okay. Now let's imagine a system you folks are probably familiar with here. Let's look at a student table and a course table. Right? So this is course, this is student. Okay, so you have an ID, course has an ID, a department, student, you have an ID, a name, a major, that sort of thing. Sure, all sorts of information. So, how do these relate? Right, so we might imagine, you know, you had like CIS 2454 as a course, and maybe CIS 1200 as a course, maybe CIS 1500 as a course, maybe CIS 2151 as a course, dot, 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 a bunch of courses, right? And you had students, you had Bob, and Joe, Jill, and John, sure, on and on and on and on, right? So how do those relate? Well, a course is taken by many students, right? But one student can also take many courses. In fact, most of you take many courses, right? So this here is a many-to-many. This here is bad, right? Because how do we relate those together? Well, okay, well, student could have a course ID field, but then you'd have to put like course ID CIS 2151, comma, CIS 1500, comma, and we already said multiple pieces of data in one field is a big no-no. So we can't do that, right? We can't have a course ID field there. And the course can't have a student ID field either. Like, hey, student 1 and 2 and 3 and 4, comma, on and on and on are enrolled. Well, no, that's no good either, right? Because that we have repeating data, and that's a big no-no when it comes to designing our database, okay? So what we have to do here to solve this is we do something called a joining table. Joining table. Okay, so we would say our joining table here, let's call this enrollment. Because that's a noun, right? Your enrollment is kind of a noun there, right? So we got course, we got student, and then enrollment has the course ID and the student ID. Right, so one student will have many enrollments, but one enrollment has one student. One course will have many enrollments, but each enrollment has one course. So you take a many-to-many relationship and you make a joining table. You stick something in the middle, that you have a one-to-many and a one-to-many. And now this is perfectly fine. And then actually we have additional things that probably make sense to have in here in your enrollment table. You probably have, maybe they're tracking whether or not you've paid, but they're probably tracking your grade, right, as an attribute in this table. And we could keep this history then of courses you've enrolled in and your grade. Now, this is a tough concept, and a lot of people trip up on this. And again, I'm going to help you with all the database design work, building out tables, but we need to kind of understand how these relationships work. Okay? Yeah, so actually, relating a course to an enrollment is actually probably wrong. You probably actually have course to a section of the class, right? And the section then has the semester and the prof and, the day and the time, that sort of thing. So like one class would have many sections, but a section is only one course, essentially. So yeah, to fix that, right? And a section would have many enrollments. So that would be section ID, right? Yep. Yeah, so that would be more proper, right? You would break that down even further. So we could offer a section of the class. And again, it would have its own ID, that sort of thing. And then it would reference the course ID of course, right? That sort of thing. So, we don't have to worry too much about that. We're just kind of looking at this example of what do we do if we have a many-to-many? Many students take many courses. Well, that's no good. We can't do that in a relational database with following good practices. We should not do that in a relational database because of following good practices. Okay? So we do that. We make this joining table, right? Yeah, Thug Muffin, one of the best things about being a CIS major is essentially we don't have classes before 10 a.m. It's just not really a thing we do. We're computer people. Yeah. Yeah, I know I don't. Dr. Ball doesn't. I think some crazy people over at Auburn Hills do classes before 10 a.m. occasionally. But, you're trying to do a 4-hour class. You have like 9 to 1, 1 to 5, and 6 to 10. Or how we do our blocks. King, there's actually a whole body of research that says high school age students and teenagers, and even young adults, should not be waking up at 6 in the morning and getting to school at 7 in the morning or something stupid, and it's bad for them. And yet, that's what we do. So, yeah, I don't know. Go lobby your politicians. That's all actually controlled by your local school board, which is probably as local control as you can get. I don't think that's a state mandated thing at all with times. So you're not actually awake till 11 a.m. regardless of when you wake up. See, that's the problem because I didn't wake up till noon today. So I definitely was not truly awake at 11 a.m. regardless of when I woke up. I hope I wasn't awake. But then again, I was up till 7, so my schedule is just, it's terrible. But the house is quiet after the kids go to bed, and I can get stuff done when it's quiet. Yeah, back in the day, wake up at 4 to milk the cows, plow the fields, walk 17 miles to school. Yeah, I mean, I've always been a late night person. My first, no, not, okay, that wasn't the first one, no. But I used to work the midnight shift at the help desk. It was 11 p.m. to 7:30 in the morning. And actually, I really liked that shift. Aside from it being Monday to Friday, if it would have been Sunday night to Thursday night, it would have been phenomenal. But having to work Friday night to 7:30 in the morning Saturday was pretty crappy, because then I couldn't do a lot of things on Saturday. But sure. Anyway, we're digressing. So another common example here, is we want to look at how we see these common problems and how we solve them. So if you are selling widgets, if you're a widget salesperson, right? You've got a widget table, right? It's got a bunch of fields, right? It's got an ID field, of course. It probably has a name, probably has a cost, that sort of thing. And then you've got a customer table over here. Customer, that says customer somewhere. Sure. Customer, right? An ID, a name, ... If they want to buy a widget, right? One customer wants to buy many widgets. One widget is bought by many customers, right? Or many widgets are bought by many customers. Excuse me. Right, we've got this problem. I can't say, hey, I want to buy many of these. And really, we should probably track it even in an order anyway. So we should have an order then. So one order has one customer, but a customer hopefully will have many orders. And so that's one to many, many to one. Okay? And then, an order should have many widgets, and a widget should be sold in many orders. That's a problem here, right? That's our big many to many. Many. That makes us sad. That's a big sad face, okay? So we need to solve that. All right, well, what do? Well, we could have, say, maybe an order item or order widget. Usually, I don't know, usually they call that item, but we'll call it an order item because that's easy. Right, so we have an order item table. So one order item relates to one order, but one order can have many items. One item relates to one widget, but one widget can be sold many times, can be in many orders. If you say what part backwards, Kleenex, makes more sense. One to many, many to one. Oh, okay. One to many, many to one. All right. So now here's an interesting thing, and this is something you usually get into in the database classes as well. But if I have a widget here and it's ID number 1 and it is, a hammer or something, and it costs $5. In my order item table, I'm going to say, okay, this is item number 1, so this is a widget ID, and it's order ID. I'd say widget number 1, order number 1. Great. So order has number 1. Order might have, an ID. Other information about it. I don't know whether or not it's paid. Yes or no, that sort of thing. Sure. This is all good and proper. We don't have any duplicate data. But now, what happens if I need to start charging more for my hammer? Right, the place where I have that information here is in order. So I'd say, oh, I need to charge more money. I'm going to charge $6 for that hammer now. Now, the customer, when they ordered it, we told them it cost $5. And now when they go to pay the bill, because we said, oh, look, your order isn't paid here. This was no, it wasn't paid. We're going to send them an invoice. We say, oh, okay, well, let's look up your order. It's not paid. Let's go find all the order items, you know, where order ID was 1, maybe the bottom widget 1, widget 2, widget 3, something like that. Sure. Okay, you know, and 2 and 3, dot, 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 whatever here. We say, oh, now that hammer costs $6. They're going to be upset with us. Because when they ordered it, it cost $5. Right? So sometimes what you have to do is you need to have additional data here, like cost. And we could essentially duplicate it, but it's not really a duplicate because it's the cost at time of order. So you might feel a little bad that you have all this duplicate data, but you know, you want to make sure you're maintaining that cost here so that if you change the price later, you haven't changed all of your orders. Right? So sometimes we'll have additional information like that in these joining tables as well. Okay? So now I can say, oh, sure, it cost $5 for that item here. Maybe this, I don't know, whatever, it was $1 here. Maybe this one was $10. Right? Okay, so this is all about tables. How you folks doing so far? Again, if you've already hit 1200, I'm sorry, this is probably pretty boring. If you haven't, this is probably going really fast. Again, it's just to get the concepts down, and then we're going to look at how we actually do it in MySQL Server with the Phpmyadmin. We'll make some tables and we'll play with them. And we're going to start talking all about writing structured query language. It's a lot of fun. Cool. All right, Sticks. Good to hear it. All right, so I think we're pretty good in terms of design for now and looking at, you know, how tables are going to relate to each other, that sort of thing. It's not quite as technical, Sticks, as what you might get into 1200. But again, I'm going for the quick and dirty overview here. You have a table that has when the price changed. So I think, you know, when you change the price, you would just change it in widget, but then order item would maintain that cost because when they ordered it, we're going to take that. Right? We're going to take the current cost at time of order because we don't want to charge people more money. Uh-oh. Is he a naughty cat? This kitty's getting into trouble. Say hi, Merlin. Say hi. Okay. Cool. So why don't we take a little break? I've been talking for about an hour, and the next topic's going to take a little bit of time. We'll come back to using the MySQL server, or Phpmyadmin for MySQL, or essentially MariaDB. Again, doesn't matter. Oh, you're purring now. Are you happy? Mama kicked you out? Yeah. Sorry, I'm a big cat person. Never could have him as a kid because my brother was allergic. But my grandmother had cats, and I always, when I go visit, I play with her cats, and I always wanted the cat. So, all right. Cool, so we'll take a little break. I'll put some music back on. We'll come back in about 10 minutes or so. Go get yourself some fluids. And then we'll come back and look at actually interacting with the database. And we'll start talking about structured query language, the language you use to talk to databases, which is all sorts of fun. And probably go for another hour and a half or so. So I don't think we'll need a second break. I think we can just power through whatever we need to do from there. Okay? So let's put some music back on. Put on our break time screen. We'll say about 7:08 or so. I think this gives us 10 minutes. And we'll go from there. See you soon, folks.
Mike's Hard Lemonade Seltzer is a hard lemonade seltzer made by hard lemonade experts. So why drink hard lemonade seltzer from anyone else? You wouldn't get hip-hop recommendations from an opera fan. Each track is like 2 hours long, and you'd feel underdressed. So choose crisp, refreshing Mike's Hard Lemonade Seltzer with 100 calories and 1 gram of sugar, plus is gluten-free. Find it in stores near you. Nobody makes lemonade like Mike's. Please drink responsibly. Hard seltzer with flavors. Mike's Hard Lemonade Company, Chicago, Illinois.
DTE believes that leaders do what's right, not what's easy. So we're building the largest wind and solar installations in the state and using cleaner natural gas. And over the next 10 years, we'll triple renewables and cut carbon emissions in half. We're committed to a future where affordable, reliable energy doesn't contribute to climate change. Because to lead, we have to do what's right. Learn more at dtecleanenergy.com. DTE.
This is Ice-T and Stone Cold Steve Austin, and
This is a cold call.
We're on a mission to get America to switch to cold water washing with Tide.
it saves you energy.
And that saves you up to $150 a year on your energy bill.
Plus, Tide cleans better in cold than the bargain brand in hot. So what are you waiting for?
Turn to cold because Stone Cold said so.
Turn to cold with Tide.
Energy savings based on average when switching from hot to cold and non-HE machines. Performance based on Tide Power Pods versus leading baking soda packs.
I miss the family I used to have. I feel like everything's so different now. Sitting by the fire as we'd watch the flames burn out. I miss the days I wasn't afraid. Now I always have my guard up. Hands on my face, I learned to cope with the pain. I know that people think I'm trying to get attention, but in reality I'm trying to send a message. I know there's kids out there that are going through the same thing, and if you're one of them, I hope to help your suffering. Just know it will get better and these feelings do not stay the same. No, they don't stay the same. I don't wanna make you feel bad, but you kinda ruined my life. You hurt me and ruined my life. And I don't wanna make you feel bad, but you kinda ruined my life. You hurt me and ruined my life. You hurt me and ruined my life. Oh. You hurt me and ruined my life. I lost a couple friends on my way up. I took a couple L's, but that's just normal talk. I popped a couple pills, but they don't do much. And now I take Prozac in the morning with some other stuff. But why did I get into this? I feel like this is all a dream. But when I wake up, look around, this isn't even make-believe. So I sit in the corner thinking back to all the memories. I grew up with these fake beliefs, by the time I find a remedy. I don't wanna make you feel bad, but you kinda ruined my life. You hurt me and ruined my life. And I don't wanna make you feel bad, but you kinda ruined So you wanna go to war with me? You're talking like you think you're royalty. You think that I'm afraid, but I don't break. I heard you question my stability. You think I'll fall just like a guillotine, but I am here to stay. Won't look away. The storm is coming, so you better start running. No, you can't control, feel it in my bones. I'm coming for the, coming for the.
Hey folks, welcome on back. Alrighty. Okay, I know I've seen some extension. There's also like a Captioner website. He uses Captioner, doesn't he? What is it? Web Captioner? Web Captioner? I think that's what it is. I think this is. I asked him one time what he uses. I think that's it. Start. Oh, nice. Only works with Chrome. This is a Chrome OS browser. That's sure. Okay, why not? Oh, you know, I don't even have Chrome installed. So that might not work, will it? Yep. All right. Yep. No, I can't use Web Captioner. I totally uninstalled Chrome from my computer because Chrome is generally garbage. Sorry, Rat. Yeah, I think that there's a Twitch extension too that does something like that. But I know for sure it does it on the YouTube exports. So if it's all right to lean on that, that's my current plan. All right, let me grab this here, make sure I'm covering all the right stuff. Let's see. All right, awesome. There we go. Yep, tables. All right, and now we're going to look at table organization. Oh, I need a single page. There we go. All right, awesome. So the chapter 3 in the text is pretty good. Okay, sweet. Thanks, Crow. I'll take a look. All right, so we're going to define the table here. So let's pull open our Phpmyadmin. Got that in Firefox, that's right. And I'm going to make a new database for this. So there's a couple built-in ones. I did everything before in test. I'm going to make a new one here. And we'll call this one our... Come on. Let's call it a college. Make it a college database. All right. Sure, general, that's probably fine. Create it. Cool. So we'll make one. So we have a college database to play with here. Oh, I forgot one other thing too. You know, we can do that next week. You want to set a password on Phpmyadmin at some point. I'm assuming doing all this local development, we're not actually going to put anything in there of consequence, but it's always good practice to put a password in. So, well, we can do it now. So you go to user accounts, and by default we're using root, and I already have a password set because I went and set it here, and it gets a little funky on localhost. ::1 is your IPv6 local address, and 127.0.0.1 is your IPv4 local address. So I usually do the one on localhost because that's what it comes up here. You can go and you can set a password for it, and that's a good habit to get into. But then you'll need to go and change your Phpmyadmin config to add the password. You can do that in config Phpmyadmin config here. And you'll put in the password. So it should be blank to start. I just put in the password of test when I set it. And then it should start working again. Otherwise, it's going to break. So again, you don't need to put a password in. It's a good habit, and I recommend you do. And if you run into any trouble with it, let me know. We can hop on a screen share session and get it up and running. But you know, the password's just tested. For me, it's nothing exciting. But no one is accessing my computer from outside my network anyway, so I'm not too concerned about it. Again, not what we do in a production setting. This is like for development here, that sort of thing. Okay. All right. So anyway, so we made a database for us to play with. The MySQL database has all sorts of information about MySQL, so we don't want to touch that one. We're going to go to the college database. It says, hey, there's no tables, so let's make a table. Put in a table name. So this is the student table. And how many columns? Sure, 4. We can start with 4. You can always add more. So I'm a big fan of using this tool for it. You don't have to use the tool for making databases. You can do it all in this SQL or structured query language. There's two, I don't know, types is the wrong word, but two styles of structured query language. One is called DDL for data definition language, and the other is called DML for data manipulation language. So all the things we're using the tool for here for building the tables and defining our data, that's the DDL, the data definition language. You can do that with SQL code, which is great. We don't have to use a visual tool for it, but this is just so much easier. Okay. And the DML, the data manipulation language, is what we're going to practice with. Well, that's what we're going to learn in a little bit. But we need tables first. All right, so we need a field. So we'll call this an ID field. The type of field is the type of data that you're storing. Our relational database management system wants to know what type of data we're storing. Integers. Varchar is a variable number of characters. So this is, varchar is usually pretty good. Text is larger, so it's 65,000 characters. Versus varchar is flexible, variable length. I mean, text is also variable as well, but varchar is pretty common. And then dates for dates and times. Dates are really hard. They're just hard. Date is a hard thing. You can have date and time. You can have a timestamp. Other types here. Hey, have a good night, 7. Thanks for coming on by. We'll work with binary data later. All sorts of other fun types. JSON's fun too. But for now, int. So in integer, again, we're not going to have more than 2 billion of these, so I'm not worried. You can make it a big integer if you need to. But for now, int is probably pretty fine. And then we're going to go and scroll. Where's our scroll here? This one. Scroll over. This AI is for auto increment. So the field is the ID. That's going to be our primary key. We're going to say this index is primary. You can also say it's unique. And index is another thing. It's not going to matter for us. Databases behind the scenes use indexes for quick lookups. We're never going to mess with them. So we'll say this is a primary key. Sure, primary key, int. Yep, good. Go. And auto increment. We want it to auto increment for that field. That way it will pick the next number for me all the time. All this other stuff we don't need. Okay. And then we'll have maybe a name here. And that's probably a varchar. And when you give a varchar, you give it typically a max length. If you can give a max length, it's going to be a little bit more efficient behind the scenes. It's not the worst thing in the world, but you know, some names are kind of long. So if we go with 50, we're probably pretty good. I know all my kids, my wife, have a hyphenated last name, so they have 15 characters just in the last name. And they also have 2 middle names. So if you do first, middle, and 15 character last name, you can get pretty close to that 50. So that's probably pretty safe for now. Again, you can change it later. It doesn't matter too much here. And then this field that says null here, if it's okay to not have a value, you check that it's okay to be nullable. Null fields are really awkward in database land, and we try and avoid them as much as possible because, you know, if it's not present, does that mean the data's not there? Or does it mean that it just has no value, or that sort of thing? So like if you're putting in, I don't know, like someone's first, middle, and last name, you might have a first name field, a middle name field, and a last name field. If the middle name is null, does it mean you don't know their middle name? Does it mean they don't have a middle name? Does it mean the person typing the data in didn't type it in? Nulls are kind of ugly, so I do my best to avoid nulls if possible. We'll have ID, we'll have name. What else do we have? We had like a major here. and that was going to be a varchar, probably 50 as well. I don't know, maybe 100, right? Associates have applied. Those get a little long. And then I don't know what email address. Sure, email address. And you want to avoid spaces. Spaces are bad as well, so don't do spaces. And that's, you know, varchar again, probably 50. I don't know if you have super long email addresses, maybe we can go bigger, 100. It's not going to hurt anything to go bigger. They're just defaults. Right? Now what you can do, if you want to see that DML, the data manipulation language, you can click this preview SQL, and it's going to tell you this is the command it's running. You could essentially copy paste this in, but we don't need to. We just hit the run button. So it's creating a table in the college database named student. It has an ID field that is an integer. It is not null. It will auto increment. It has a name, which is a variable character field, size 50. It is not null. It has a major field, variable character size 100, not null. Email address, variable character 100, not null. A primary key of ID, and then engine, sure, whatever. We hit save, and it goes and runs it for us. And now we have a table. Yeah, first dot last at oaklandcc.edu. That could get a little long. Cool. So now we got a table. We got the student table. Now we can add some data. So in here, then, I will... my goodness. Where did it go? I always get confused with this. I think it's browse. The browse? No. Table. Insert. It's right there. There's just too many things going on with this tool. So I want to insert a row into the table. And insert then gives me a nice little form to fill out here. Okay, so ID, we leave this blank. So we don't need to give it a value because this is supposed to auto increment. So we don't worry about it. So we give it a name. Variable number of characters. Name. How about Eric Chernesky? Major. Doctor engineering in automotive systems and mobility. There we go. Good thing I did 100. And email address. etchnr1@oaklandcc.edu. Okay. So you just fill out the fields here, and we can add some data. Go. It says, hey, this is what it runs. Right here. This here is DML, data manipulation language. This is an insert command. Insert inserts data into your table. Right? It adds the data. If you're familiar with the term CRUD, for create, read, update, and delete, your typical CRUD operations, this is the create. Inserting, creating data. We'll look at reading, we'll look at updating, we'll look at deleting as well. Okay? But now if I go back to my table, I'll see here's the one row. And this is the query it's running. Select star from student. This is DML, data manipulation language. This is the read. Create, read, we're reading. So select is for read. Insert for create, select for read. Okay, and it's going to give me all of the fields with their values. Not so bad. Okay. Now let's go make another table. I'll make a new table here. Let's call this one, how about course? And again, this is just an ID. We want it to be the primary key, and we want it to auto increment. Yeah, primary key, auto increment, great. And then probably has a department and a number. Sure, like CIS, and then 2454. And how about a name? So department there should be varchar. I'd imagine 4, but you know, let's make it bigger just in case. The number. I've seen some weird things, so you might not want to use an integer field here, right? You know, so people stick on L's for labs occasionally, that sort of thing. It came installed with XAMPP nav. So just start your Apache server, start your MySQL server, and then you go to admin, and it should launch to localhost, your port number, /phpmyadmin. Forgot to grab another drink. Dang it. I'm going to be thirsty. Maybe we need another quick break in a little bit. Notice this is the tblcreate.php page. This is a PHP tool for administering MySQL Server. And server number, database is college. That's a GET request. Okay, so again, course number, sure. I'm going to leave it a little bigger than just in case. We don't want to run into issues here. And then name, that's varchar, probably give that like 100 characters or so. Okay, and we'll create that table. Cool. So now we have the course table. Now let's add the... Should we add section? We should add section. That's probably proper. So section will have an ID. It is the primary key. It should auto-increment. Section then has maybe a semester. It should be variable character. Summer, a year. So probably like what, 4 digits for a year. SUMMER6. So 10 characters ought to fit, right? Winter, summer, fall, those are all, yeah, those all fit. I think that works for 10 characters. So the section is for a given semester. And then what else? We wanted the instructor. And that's probably going to be like the instructor ID, right? We don't have an instructor table yet, but we can come back to that. And meeting day and time. Sure, we'll just say meeting daytime. That's fine. So instructor ID will be an integer. Daytime we'll just make varchar for now and just make that 50. Again, probably not exactly proper. There's better ways to sort these sorts of things, but it's not anything we need to do right now. Okay, not anything we need to worry about right now. And we don't set any indexes on our foreign keys yet. Oh, it needs a course ID. That's right. So let me add another column. Add one column. There we go. This is course ID. There's an integer here. We'll reference that. Okay. We'll save. Now we need to make this be a foreign key. So we need to make course ID relate to the course table ID field. So I can go to relation view. I don't have any right now, so we're going to add one. We're going to say, hey, course ID relates to what? Okay, well, it relates to the college database, the course table, the ID field. This on delete and on update is really important. So there's this option called Cascade. I'm going to tell you never, ever, ever use it. I don't know why it exists. It's a terrible option. What that means is if someone were to delete the course, it should also delete all of the sections that reference that course. It's a really bad thing to have happen in a database. It makes for a terrible day for somebody for deleting data. And again, we'll give it a name. I'm fond of FK. I don't know, like course ID or something. I don't know, course ID. All right, any luck now? All right, I'm sorry, folks. That's super weird. That's just really weird. I restarted. It just totally dropped the connection and restarted me here. It's weird. I'm supposed to have the disconnect protection too. I don't know. Sorry about that. Let me give it a second in case anyone refreshed and got another ad. Maybe that's my sign to go get my Perrier. The matrix glitched, yeah. right, I think we're good now. So we'll pick it back up. So we're looking on the enrollment table. And that's our primary key. It will auto increment. And then we'll have a section ID as an integer. And we'll have a student ID as an integer. And then we'll probably might as well have the grade, right? Which is a varchar. I think that's only 2 characters, right? Letter plus minus. Probably fine for 2 characters there. We'll save that. And then we're going to go to the relations here, the relation view, and then we'll go set up our keys. So our section ID relates to the college section ID table. We'll call that foreign key How about now? Alright, I'm sorry, folks. That's weird. It failed and said, couldn't even find the DNS. That's super weird. When Elon Musk tweets, it crashes, yeah. I blame Comcast. Yeah, DNS should not time out. That's super weird. Not a switch, is it? Let's see if I can do some other lookups. That's super weird. Huh. I don't know, folks. I'm sorry. If you don't mind, we'll keep trying to power through. If it gets too bad, we can bail, but hopefully it'll work. Okay, so we added our foreign keys for our relationships here. And I also realized course should probably have credits. So if we go to course and go to structure, we can go change it here. We want to add a column after name, sure. And this will be an integer. This is credits. Here, we've got a save. Great, and it worked. We're able to add it. Okay, so let's go back to course and let's go insert some data here. So again, you leave ID blank. So this is CIS, this is 2454, this is web systems development, PHP and JSP or something like that, and for 4 credits. Cool, so now we have a course. Let's add another one. Let's insert another one. How about CIS 1500, Intro to Programming, Java, for 4 credits. Cool, so we got 2 courses here. I like it. When we look at the course table, we should see them both, right? ID 1, ID 2, on and on and on and on. We could add as many as we wanted, right? We don't need to go too crazy. All right, I've got a student. Let's add a section here then. So now I'm going to insert. Now what's really cool about this is because course ID is related as a foreign key, I get a drop down here. Now I don't see all of the information, but it tries to give you a little bit of information here. So like, hey, course 1, CIS. So I'll have to go look it up and see which one it is. But you get a drop down field of possible options, which is nice. So this is summer 2021. And instructor ID, sure, I'll be instructor number 1 or something. This is Thursday, 6 to 9:45 p.m. You know, this is probably wrong for this field, but that's okay. We're not going to feel too bad about it. Okay, so we added in a section. Now let's add an enrollment. Let's go insert. So section ID, section 1, student ID 1, great. Course ID, fine, and grade. Oops, now this one is probably okay to be nullable because we don't have one for now, but you know, I didn't make that nullable because you're not going to have a grade. I don't know, maybe we just put something in here for now, like I don't know. And it's not ideal, but that's okay. Don't worry too much about it. Now we have an enrollment. Okay. So all of that now, so that we have some data in our tables. Now we can hit this query button. So query lets us write our own SQL. I don't want query by example. I want to write my own query. So you can do your own like drag and drop, which is pretty cool. Or you could just type it in. So, they do a nice job giving you some like, what do you want to grab, that sort of thing, but that's fine. We're gonna handwrite it here because it's not so bad. So remember, we looked at someone, they say select star from course. Are you sure you want to leave the page? What? That was weird. And we get the course data here. Right? So select is how you read data out of tables. We're saying, and star is the key for everything. If you wanted, you could say select, if you just wanted department, comma, number, comma, name from course. We could run that. No, why is it doing that? I don't know. It's okay. Submit's being weird right now, but that's okay. And now you see I don't get the ID back out. So you can give individual column names if you want here. Okay. So that's just a basic select from a single table. The other thing you get to do now with selects is you can give it a condition. So you can say, hey, I only want to see it if something is true. And maybe we say, we need credits too, right? Credits. Right, there we go. Yeah, 4 credits. And maybe we'll say where number is greater than or equal to 2000. So where is the restrictive clause that says only return results where this is true. So it's going to look at all of the courses here, and it's only going to give you results if this is true. So now we just get the 200 level classes or 2000 level classes here. That's our where clause. Okay, so there's select columns from table, where, and you can even order things if you want. We don't have enough data to actually order anything. It's not super interesting. All right, so that's for a single table. Now, here's where it gets fun. We have relations, so to use those relationships, we need to add some additional SQL here. I'm just going to go back to select star, because that's fastest for right now. So I'm going to select star from course, and then I'm going to say inner join. So inner join says, give me results only where there are matches. So take this table and join it to this table where you have matches on the primary keys and foreign keys. That's the join. So we're going to say join section, and then you tell it how it's going to join it. You say on section dot course ID is equal to, and unlike programming, most programming languages, just the single equal sign actually does mean equals here. You don't need the double equal sign. Equals course dot ID. And I can submit that one. And now I'm going to get all of the fields. So I get all of the course fields and then all of the section fields. So you get them in the order in which they're listed. So if you say from course, join section, you'll get course fields, then section fields. Okay, and notice we didn't get the CIS 1500 course because there was no section for it. Right, so because we're doing this inner join, you're only getting results where there is a match. Okay, but then we see the semester, the instructor ID, the meeting date and time, and the course ID again here. Okay, so let's go back. Let's add another section here. We can leave the page. You can save queries and kind of bookmark them. It's kind of fun. Let's go insert another. Excuse me. So let's say this was winter 2021 for Thursday. Sure, why not? And we'll do this one for the 1500 class. All right, I'm going to come back here and do some more queries. All right, again, that was select star from course, inner join, right, to say connect the tables using their foreign key relation, inner join section, and how, where do they relate? So you can technically join off of other relations. It's just usually awkward and probably won't work very well. So on section.course ID is equal to course.id. Right, now we're going to get both. But now in here, like I could say, okay, how about where semester is equal to, and now you have to give it in quotes here, right? So you can't just say summer 2021. It has to be a quoted string here. So single quotes in SQL, or single apostrophes. So hey, just show me all the sections in the summer, right? Or show me all the sections where instructor ID is 1. Hey, that's me. I teach both of those, sure. Right, so that where clause can be used to limit the results. I think I can make that a little bigger. There we go. So this is, again, this is just selecting or reading data. So if the CRUD operations, create is select, to create is insert, read is select, update is actually update, and delete is delete, which is fun. So create, read, update, delete, CRUD are common operations that you'll do with the database. Okay, so we can join multiple tables. There's technically another join, which is an outer join, where you get all the results, and then if there are no matches, you just get nulls back. It's not as common, but you can do it. Again, this isn't the database class, so I wouldn't worry too much about it here. Okay. So if we wanted to do our own inserts, right, we can say insert into student, and then what we do, we give it a set of parentheses. And in the parentheses, we give it all of the fields that we're going to provide. Hey, Blowfish, thanks for coming on by. So I know that ID is auto-generated, so I'm not going to do ID. I'm going to say, hey, I'm going to give you name, I'm going to give you major, and I'm going to give you email address. And then you say values, and another set of parentheses, you give it those values. So for name, how about we add Blowfish? Major, you can be a CIS major, computer information systems, and your email address, blowfish at Fugu, end parenthesis. So this is the insert. This is the create. You say insert into what table name, then you give it the list of columns. The reason we need the list of columns is because we're not providing it the ID field. This is technically optional if you provide it all the fields. But again, it can get a little funny because you need to give them in the right order. So by declaring the columns here, we're telling it, I'm going to give them to you in this order. So this is a good way to go about it. And we'll submit. No, I don't want to leave. That's weird. And we'll go back to student. And now we'll leave the page. Sure. I think it wants to save all the time. Now we'll see Blowfish. Here he is. Now we got another student. So now let's add an enrollment. Oh, I did one enrollment. Okay, so let's go back. We'll do some SQL here. Oh, that's right. You don't have to do query. You can do it right from SQL. That's okay. So query gives you all the visual stuff. I'm sorry. SQL is going to be a little cleaner here then. And then hopefully it won't do all those prompts. So we'll select star from course. We're on an inner join section on section.course ID is course.id. And then let's inner join enrollment on enrollment.id. Oh, I'm sorry, enrollment.section ID equals section.id. And we'll inner join student on student.id is equal to enrollment.studentID. Right? So this is all those relations. Course relates to section on this foreign key relation. Section relates to enrollment on this foreign key relation. Enrollment relates to student on this foreign key relation. We're going to list them all out. We'll say go. So now we only get the one because that's the only one that has an enrollment. Right? So student ID 1 here, and we can just keep scrolling on over, which is me, is enrolled in the course. So this is where that outer join might be interesting. Edit. So you could say left outer join. And that means it will give you all of the courses, no matter or not if it matches a section. It will give you all the sections, regardless of whether or not it matches an enrollment. It will give you all the enrollments, whether or not it matches a student. So now I see 2 courses, but I get a bunch of nulls because it has no enrollments. Now, if we go the other direction, here's where it gets interesting. We could go the other direction, and we'll say select star from student. And then we'll left outer join enrollment, we'll left outer join section, and we'll left outer join course on course.id is section.courseID. Oh, wait. Oh, wait. Okay. Sorry. Join student. Join enrollment on enrollment.studentID is the student.id. Okay, that didn't copy paste as well as I was hoping. Enrollment joins to section on section ID matches enrollment section ID, and then section joins to course on course ID equals section.courseID. So this way I get all the courses and nulls if there's no enrollments. This direction, right, it goes in the order in which you declare them. So it will give me all the students, then the enrollments, then the sections, then the courses. So now I'll see I get Eric and Blowfish along with the courses and sections that Eric's enrolled in, and nulls for Blowfish because he didn't enroll in any courses. He's just a Twitch leech. Okay? So you just can be a little careful. The order in which you do them matters because it gives you that data and then it tries to match on the next set based on what you tried to do. And don't worry too much about the outer joins. Just know that they're there. All right, let's go do some more queries then. Let's look at some updates. Let's do update enrollment set grade equal to A. And maybe where, I don't know, student ID equals 1. So if I look at my enrollment section now, I see the new tab, so I didn't blow it up. I should see Eric, I put the U grade in, unknown, I don't know, whatever, right? Sure, I had a U grade. Let's go and update. So the update for create, read, update, delete is an update command. You say update the table. What are you changing? You're going to set what field equal to what, and then the where clause is optional, but almost always strongly, like, you should probably always have a where clause when you're updating, because otherwise you update the entire table, which is rarely what you want to do. So just where for this student. So I'm just giving myself all A's here. We'll go. I'll come back and refresh this one. Again, select star from enrollment. Now I should see I have an A. So if you have database access to the college management system, you can go in and change your transcript. Right? You can pretty well believe that system's going to be locked down and pretty hard to get into. And I'm sure they don't give most people access to run queries on the database, because that would be a bad thing, right? To go in and just tweak your transcript. All right, so let's update, and then you can also delete. So let's go back to college. We'll run some more SQL. So you'd say delete. You say delete from what the table name is. So let's delete from student, and then if you don't give the where clause, it's going to delete everything. If I just hit go, ooh, it fails. Cannot delete or update a parent row. A foreign key constraint fails. College enrollment constraint foreign key student ID references student ID. Remember when we were making those foreign keys and we said make sure you don't pick the Cascade thing? SQL failed. It threw up on us. It didn't run. So let's do this where name equals Blowfish. Let's go delete Blowfish. Now if I run that one, it's going to delete just fine. Bring it back to student, and now he's gone. So it's delete from table name where whatever our criteria is. And again, it can be greater than, it can be less than, it can be equals. You can have all sorts of operations there. Okay. So we're using the Myphp Admin. The book will walk you through setting that password as well. You can pick all those. If you want to use their book examples, you can go through and download their examples. They have a little create database script. You just pop open the SQL tab and hit run, and it loads it all for you. And I'm not a big fan of going through the book's examples. I'd rather give you some other ones. That way you're seeing two different examples, right? So I'm going to try and give you my own examples, and then you can look through the books if you want to follow theirs along as well. Okay? SQL results. The other thing to do, and we'll do this next week, you can make a specific user with limited access, and that is the right thing to do, right? This user root can do anything and everything to the MySQL database. Can really screw things up. So when we're building a application that uses a database. What we're going to do is we're going to make a user specific for the application that has just the permissions they need, which is typically just the data manipulation language. Most of the time, you don't want to give that user access to the DDL, the data definition language, because you don't want them to create tables, you don't want them to drop tables or update foreign keys or add constraints, those sorts of things. So we're going to limit the user to just select, insert, update, and delete statements. Right, and we'll look at that when we look at actually doing SQL in PHP. Yeah, for sure. Limited access, because otherwise they will blow things up. For sure. Okay, and then next week, we'll come back and look at actually using this in PHP. This is a lot to swallow, and we still have Project 1 to work on. Again, this is, all of our classes are designed to be lab-based classes, where I'm not talking the whole 3 hours, 45 minutes at you. I'll talk for a good 2 hours or so, and I'll say, hey, you go try it now. And I can walk around the room and help. And I've not been able to duplicate that. I know one of my colleagues tries to put people in breakout rooms and say, oh, you guys go try it in a group and then come back and tell me what happened, and he jumps around the breakout rooms, and it just sounds horrible to me. So my preferred plan for what we'll do is I'll talk till about 8 p.m. or so, and then I'll say, okay, go try the stuff, and if you have questions, come talk to me individually, rather than forcing you into Zoom meetings and breakout rooms and those sorts of things. Okay, so that's it for Chapter 3. Just try it. Make sure you can get Phpmyadmin open. You'll be good to go. When we get to next week and start on Chapter 4, I'll start building out a little PHP application that talks to our database, which is a lot of fun, and that's what we'll do for Project 2. We'll do a basic little, hey, we're going to make an application that actually reads data from the database, lets you add data to the database. We may or may not do deletes or updates. It depends. We'll see how far we get next week. But that's sort of the plan. All right, so that's all I've got tonight, actually. Oh, very cool. Sticks. Yeah, C# and SQL is a lot of fun. I'm a big fan of that, for sure. Yeah, but there's some really cool frameworks as well, but you can always do it by hand as well. I know when I teach the C# class, we'll use Entity Framework for talking to a database, because I'm a big fan of it. But it doesn't always work in existing projects. So, cool. So if you don't have any other questions, we'll call it a night. We'll go raid somebody else on Twitch land and see who's around. Let's see. Then we can go from there. Okay, so let's chat offline. Why don't you send me a message in Discord or send me an email? We'll set up a time to meet. All right, let's see. Who is around? Never could raid our channel, could we? No. Ooh, Rocketology. Let's go check out Rocketology. That should be a lot of fun. Make sure I can spell this right, though. Rocketology. All right, cool. We'll head over that way. Everyone say hi. You folks have a good night. If you got questions, find me in Discord or shoot me emails, text me. We can go from there. You folks take care. See you around.